So then what are the processes that affect salinity in the ocean? This becomes important because ocean has two types of circulations, as we will see later on. One is directly being dragged around by the winds of the atmosphere at the surface, and the other one is because salinity changes, and that changes the density of the water, and that creates a density driven circulation. So what are the processes that decrease salinity? Basically, if you add fresh water to the ocean, that's going to decrease the relative amount of salt in the water. So rivers running into the ocean, melting of icebergs, as we will see later on. When ice forms, it rejects all the salts. So the colder it gets, the more it squeezes out the gases and the salts. And when it melts, it's going to add fresh water. Sea ice, which also rejects salt, it's called rejection of brine, as we will see later. So melting of sea ice also locally reduces salinity, and of course precipitation, any rain that falls. Remember, as water evaporates from the ocean, it leaves salt behind. So it cools the surface and it leaves the salt behind. So it's cooler temperatures tend to increase the density above 4 degrees centigrade, and salt tends to increase salinity. So evaporation can make for heavier water. So when precipitation falls back, it makes for fresher water. So if you go in the ocean where there is a lot of precipitation, like the Western Pacific, west of New Guinea, where about 5 meters of rain falls per year, you can find very, very fresh water. And the polar latitudes where we saw that evaporative latitudes are moving precipitation and dumping it all there. Arctic Ocean, for example, is very fresh. We will see the contrasts in a little bit. Increasing salinity is anything that you remove fresh water from the ocean, like sea ice formation. Sea ice rejects brine, rejects salt, so increases salinity of the ocean and creates fresh fresh sea ice with fresher water. Evaporation, so for example, if you build glaciers, like during an ice age, you're going to move lots of water from the ocean onto land and freeze it, so you're going to increase salts in the ocean. So these are some of the processes affecting salinity: precipitation, runoff, iceberg melting, sea ice forming, and evaporation. How are they accomplished? There are obviously very simple processes involved, and some of them add salinity and some of them remove salinity. And effects on salt in the seawater: precipitation. Essentially, if you're evaporating from the ocean and dumping it back onto the ocean, on average, then you don't change the salinity too much. That's what is being said here. But the water in the ocean is going to be increased. Salinity will decrease, right? Salt in the seawater and salinity are different. Total amount of salt and salinity, right? I hope you understand the difference, and so on. So I won't spend too much time on it, but you can stare at this table for a little bit. Anytime you melt glaciers, right? Glacier is something that is built on land. We'll see what a glacier is as opposed to what a sea ice is. Sea ice is in the ocean, it melts, it's going to add fresh water, and it's not going to change sea level. It's like melting a ice cube in the glass itself, whereas if you add additional ice, that's going to change the level of water in the glass, right? So melting a glacier is going to add water that was not in the ocean, that was sitting on land, and so on. So these kind of differences we have to understand. The big concept to come out of this eventually is what is called the hydrologic cycle. There are lots of places where evaporation is happening. There's lots of places where precipitation, and you have to remember, precipitation is not just rain. It also includes sleet, snow, hail, and so on, right? So processes that affect salinity are the hydrologic cycle. It is the way water is recycled between the ocean, the atmosphere, and the continents. And water is constantly moving around. Remember, we said energy has to be transported. Essentially, you are evaporating from the tropical oceans and subtropical oceans. A lot of it is falling back as rain on the tropical oceans, but the energy is being released into the atmosphere. subtropical latitudes are evaporating and moving. So water vapor in the atmosphere is energy, because when it condenses, it releases the condensation energy, right? So this is showing some estimates of cubic kilometers of water you are moving from the ocean to the atmosphere, atmosphere to the ocean, atmosphere to the continent, and so on and so forth. So you have lots of evaporation happening here. For example, 320,000 cubic kilometers of water being evaporated from the ocean. 284,000 kilometer cube of it is falling back on the ocean, and a percentage of it is being taken onto land, but obviously that flows back into the ocean as rivers and groundwater and so on. Land, soil moisture, lakes and other things are losing about 60,000 kilometers, and that's being either raining locally or being transported onto the ocean. On dry regions, for example, donate water vapor to the regions where it rains, and rainy regions obviously take moisture from the places that are donating. So precipitation on land is about 96,000 kilometer cube, runoff is 36,000 kilometer cube. A lot of it is infiltrates into the ground. So the time scale of runoff at the surface and groundwater tend to be very different. So there are various time scales involved here. Evaporation is very fast. Condensation and clouds can hang around for a long time. They get moved at a long time scale to higher latitudes, or rain and so on. So we won't talk much about time scales, but there is many time scales involved here. We will see an animation of these various things later on. Okay, so Earth's water is basically almost all of it in the world is in the world ocean, more than 97%. And out of the remaining less than about 3% of the fresh water, more than 2% is frozen in glaciers and ice cap. Okay, so remember that only about 3% fresh water is available in the world. More than 2% of it is locked up in glaciers and ice caps. So all the water that we're using for industries, for agriculture, for human usage, and entertainment, swimming pools, everything else is about 1%. So 0.62% of that is in groundwater and soil moisture. 0.02% is in streams and lakes. So you think rivers are flowing all the time and carrying so much water, but actually that's a tiny percentage of water. And the atmosphere obviously has basically very small percentage of water. So water is very important for everything, for moving energy, for life, for ice ages, for storing energy as glaciers and so on. But the fresh water that's available is a tiny percent. This is why a lot of the countries depend on desalination for their water supply, which has its own issues, as we will see a little bit later on.